Today we will start new topic, that is types of chemical reactions. You know that there are 5 types of chemical reactions. First one is combination reaction, decomposition reaction, displacement reactions, we can say simple displacement reaction also, double displacement reaction, and redox reaction. Redox reaction stands for oxidation and reduction reaction. Okay, the first, combination reaction. What is the meaning of this combination reaction? Those reactions in which two or more substances, we can simply say that two or more than two reactants combine together to form a single substance, are called the combination reactions. Means that two substances, here carbon, here oxygen, carbon and oxygen are combining and giving only one product, the reactant 2 giving only one product, carbon dioxide. This is called combination reaction. So more examples: hydrogen reacts with oxygen to give water, only one product. Two reactants, carbon monoxide reacts with oxygen to give carbon dioxide. This is again one product only. NH3, that is ammonia, when reacts with hydrochloric acid gives ammonium chloride. Ammonium chloride, again one product here. Calcium oxide, water gives calcium hydroxide, or simply we can say slagged lime. This is also called slagged lime. Only one product here. In this case, see, more than two reactants, 1 2 3 reactants, sodium carbonate plus water plus carbon dioxide, these all are combining to give only one product, sodium bicarbonate, or simply we can say sodium hydrogen carbonate. This is the examples of combination reaction. So clear to everyone that combination reaction is the reaction in which two or more substances combine together to form a single substance. Now we move on to the second type, decomposition reaction. That is decomposition reaction. Those reactions in which a single substance, that is reactant, splits up into two or more simpler substances, products, are known as decomposition reaction. Just reverse of combination reaction we are saying. Single substance, this is single substance, this becomes reactant and they splits up into two or more simpler substances. Means the product side we get more than two substances. That is known as decomposition reaction. But before we start the example, we know that how many types of these decomposition reactions are. Decomposition reactions are carried out by supplying energy. Thus it is classified as follows. Energy, we said here energy. First of all, thermal decomposition reaction, which is also known as thermolysis. In this case, the heat energy is supplied. Heat energy. We will discuss this in the topic. Electrolytic decomposition reaction. Electrolysis, known as electrolysis. We discuss here that the energy in this one will be in the form of electricity. Now the third one, that is photolytic decomposition reaction, or simply photolysis, or we can say also photothermal equations. Here we see that the energy is in the form of light. Photolytic, photo stands for light here. Now the first one, to thermal decomposition reaction, which is also known as thermolysis. Decomposition reactions which are carried out by heating are called thermal decomposition reactions. Thermal decomposition reactions. For example, thermal decomposition of ferrous sulfate crystal. We have taken a test tube holder. This is Bunsen burner. When we lit this burner on, we have taken the ferrous sulfate crystals. We are heating this slowly. We see that this experiment we have written here, I have written here, that is ferrous sulfate 7s2. When we heat this ferrous sulfate crystals, which is green in color, they become white. The seven molecules of water of crystallization, that is 7s2, goes out in the form of vapor. This becomes white. This white, further if we heat this ferrous sulfate, white ferrous sulfate crystal, we see that this becomes brown in color, Fe2O3, ferric oxide. This one, sulfur dioxide and sulfur trioxide gases comes out. Getting this one, what we have written here, see this. Take a small amount of ferrous sulfate crystals in a test tube. Now heat the test tube over a burner. The green color of crystal first changes to white due to the formation of anhydrous ferrous sulfate. This is anhydrous ferrous sulfate, which is white in color. Anhydrous ferrous sulfate. As on heating, further ferrous sulfate crystal lose the water molecules. They are losing the water molecules. Clear? On further heating, ferrous sulfate decomposes to brown solid Fe2O3 along with the characteristic smell of burning sulfur. Getting? This one is the example of thermal decomposition. Some more examples: potassium chlorate, KClO3. When we heat, it becomes potassium chloride plus oxygen. Lead nitrate, lead oxide plus nitrogen dioxide plus oxygen. Some more examples of this one, that is calcium carbonate, calcium oxide plus carbon dioxide. Zinc carbonate, when we heat, zinc oxide plus carbon dioxide. These are some examples of thermal decomposition reaction. Now we move on to the second one, that is electrolytic decomposition reaction. It is also known as electrolysis. The decomposition reactions which are carried out by using electricity are called electrolytic decomposition reactions. Electrolytic decomposition reactions. Electrolytic decomposition reaction. To understand this, we will take a container and make two holes at the base of the container here. Two holes we have made on the base of the container. Fit two rubber stoppers in these holes. Here we have to place a rubber stopper in these two holes with carbon electrodes. These are the carbon electrodes you see here in this figure. These two lines, the carbon electrodes. Fill them, connect the electrodes to a 6-volt battery. We have connected this electrode to 6-volt battery. This is connected here. Now, after connecting this, fill the mug with water so that electrodes get immersed in it. Now we have to fill this mug or container with water such that these electrode must get dipped into this one. Now, after this, add few drops of dilute H2SO4. Few drops of dilute H2SO4 we will have to add in this one. Why we have to add this few drops of H2SO4? To activate the reaction, to get the reaction for that proper decomposition of the water also, we can say. In the presence of acid, this water decomposes fast. Few drops of dilute to make it good conductor of electricity. Fill the two test tubes with water and invert them over the electrodes. These two test tubes, first we will fill this one, then after we will invert over these electrodes. Now switch on the battery and keep the apparatus undisturbed for some time. We have switched on this one and then we will leave this apparatus. We will see that this water molecule in the presence of electric current in the form of energy gives two molecules of hydrogen and one molecule of oxygen. We can see here, we can write this two molecules as two volumes of hydrogen also. One molecule of oxygen, one volume of oxygen also. You can see that in this one, the hydrogen gas is formed at cathode, and this one you can see that two volumes I have written here. You can see more space here in with comparison to this one. Oxygen only one volume. Here you can see oxygen one volume. Here space C, you can see this one. Two volumes of hydrogen and one volume of oxygen is produced in the electrolytic decomposition of water. It is observed that the bubbles of the two different gases are formed over the electrodes, which displaces the water in the test tube. The reaction of this one, H2O, HN plus OHN, decomposition rate. This at cathode, what will happen? Cathode, negative electrode. The positive ion, cation, will move towards cathode. It moves towards cathode, accepts one electron from cathode, becomes hydrogen atom. Becomes hydrogen atom. This type of two hydrogen atoms combines and forms one molecule of hydrogen. Now at anode, what happens? Anode, the positive electrode. Anode, this is anion. Anion moves towards anodes. Anion, OH ion, moves towards anode. Now what happens here? This anion releases the electron over it. This releases electrons and becomes OH. These types of 4 OH combines to give 2 molecules of water and 1 molecule of oxygen. The gas collected in the test tube covering the cathode is double than that gas collected in the test tube covering the anode. This we have already discussed. On testing the gases by burning a burning candle near mouth of the test tubes, it is found that the gas with double volume burns with popping sound. We have already discussed that popping sound is for hydrogen gas. So it is hydrogen gas. The other gas with lesser volume makes a burning candle to glow more. So it is oxygen gas. This is one more example, electrolytic decomposition of molten sodium chloride. Molten, here important is molten sodium chloride. Molten words means पिघला हुआ, molten. On passing electric current through matter, molten sodium chloride, it decomposes to give sodium metal and chlorine gas. Sodium metal and chlorine gas. This is the reaction to NaCl when electric current is passed through this molten chloride. Sodium metal and chlorine gas is formed. The ionic reaction, sodium ion and chloride ion. NaCl breaks into sodium ion and chloride ion. What happens at cathode and what happens at anode? See here. At cathode, sodium, it is cation, move towards cathodes, loses takes 2 electron. Cation is electron deficient, so it requires electrons. Electron deficient, so it requires electron. It takes 2 electrons, becomes sodium metal. At anode, anion move towards anode. Anion is in excess of electrons, so it loses electrons. It loses electrons if chlorine atom. 2 chlorine atoms combines to give chlorine gas. This is the electrolytic decomposition of sodium chloride or molten sodium chloride. Similarly, we can write the example for decomposition of molten alumina. Alumina Al2O3. Same thing, Al2O3 electric current, 4 aluminium plus 3O2, ionic reaction, aluminium ion, oxygen ion. Here at cathode, cation, 3 electrons, it is deficient in 3 electrons, therefore aluminium atom. At anode, again oxide ion, 2 electron excess, therefore it will lose 2 electrons. Oxygen atom, 2 atoms of oxygen combines to form oxygen gas. Now the third one, that is photo decomposition reaction or simply photolysis. The decomposition reaction which takes place by absorption of the light, absorption of light, are called photo decomposition reaction or photolysis. Photo decomposition reaction or photolysis. Now we have to perform this experiment. Take a pinch of silver chloride on a watch glass. Simply this one. This is a watch glass. We have taken a white crystal of sodium chloride. Keep it in a sunlight for some time. For some time we will left this watch glass in the presence of sunlight. After some time we will see that this white crystals of silver chloride decomposes and gives gray silver. Gray silver. What is the reaction here? See this one. It is observed that white silver chloride turns gray due to the formation of silver metal. Silver chloride, white color, sunlight, silver. This is gray in color, and chlorine gas escapes out. Second example, silver bromide in the presence of sunlight gives silver plus bromine gas, reddish brown gas of bromine. Hydrogen peroxide H2O2 in the presence of sunlight gives water molecule plus oxygen gas. Similarly, hydrogen iodide in the presence of ultraviolet light gives hydrogen gas and iodine gas. Decomposition reactions are endothermic reactions. Endothermic, as we have already discussed, that which requires heat. We have seen that the decomposition reactions require energy either in the form of heat, light or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. So we can say that decomposition reactions are endothermic reactions. Now, decomposition reactions occurring in our body. Decomposition reactions, the digestion of food in our body. Everyone know very well, digestion is very important process in our body, accompanied by a number of decomposition reactions. It is accompanied by a number of decomposition reactions. When we eat food like wheat, rice or potato, then starch present in them decomposes to give simple sugars like glucose in the body, and proteins decomposes to form amino acids. That's the biological reaction. But here see this one, starch, formula of starch C6H10O5, whole N means N molecules of starch are attached. In the presence of diastase enzyme, it gives maltose, that is formula is C12H22O11. Simply we know this as the formula of sugar, cane sugar also. This one, when reacts with water molecule in the presence of maltase enzyme, it gives glucose C6H12O6, and proteins in the presence of pepsine gives amino acids. This is the decomposition reaction which occur in our body. Getting this one? Now, one more important thing for the case of decomposition reactions. Decomposition reactions are called the opposite of combination reactions. We have discussed that combination reaction, we have discussed decomposition reactions. Now we are saying that decomposition reactions are called the opposite of combination reaction. Opposite of combination reaction. See how we will prove this. In a decomposition reaction, one substance breaks up into two or more chemical substances. See here, potassium chlorate breaks up into potassium chloride and oxygen. One reactant, two products. Now see, while in a combination reaction, two or more substances combine to form one single substance. Two or more reactants, nitrogen and hydrogen, they combine to give only one product. So these two reactions are called opposite of each other. You see here, one reactant, two or more than two products. Two or more than two reactants giving only one product. Therefore, these two are opposite of each other. That is, thus we can say that the decomposition reactions are used in the extraction of metals, and we can say that these two reactions are opposite of each other.